جدا عشان الاجتماع بتاعنا يكون السنة دي قائم، وما نفوت سنة إلا يكون عندنا اس دي نوج إن شاء الله. فمرحبا بكم في اس دي نوج 7 اللي حيكون فيرتشوال في السنة دي. مرحبا بكم في بداية اس دي نوج 7، وشكرا جدا للشباب اللي شاركونا في الاجتماعات السابقة واللي حيشاركونا في الاجتماع ده إن شاء الله أونلاين، و... واللي حيشاركونا في اجتماعات قادمة إن شاء الله. نتمنى إنه تستمتعوا بالاجتماع ده. هو ما حيكون فيزيكال، ما حيكون بنفس الزمن بالتحديد بتاع الاجتماعات السابقة. الورشة حتكون فترتها ساعتين. للأسف الشديد برضو ما حيكون في متابعة للبراكتيكال سيشنز بتاعتنا. فالورشة حيكون في لايف ديمو لمجموعة من التكنولوجيز، لكن في النهاية ما حيكون في متابعة للشباب. طيب، في مجموعة من التعليمات والانستركشنز حنمشي عليها سريع جدا. بعد ذاك إن شاء الله حندي الفلور لداني الانستراكتور بتاعنا هنا. طيب، في الاجتماع ده حيكون عندنا ورشتين أساسيات. بعد ذاك حيكون في المؤتمر. الورشة الأولى حتكون اليوم اللي هي بدت فعليا. الورشة الثانية حتكون يوم غدا اللي هي Measurements and Tools by رايب أطلس. الورشة بتاعتنا بتاعت اليوم اللي هي Building Cloud Infrastructure Workshops. في اليوم الثالث حيكون في المؤتمر بتاعنا اللي هو في 5 نوفمبر إن شاء الله. حيكون في المؤتمر بتاع SdNOG، نفس السيتنج بتاع الميتينجز اللي فاتت، لكن بس من انها فيزيكال هي اتحولت فيرتشوال. لابد من نذكر هنا السبونسرز بتاعنا مشكورين جدا. الافرينكس، افرينك وانكس، بنشكرهم جدا على السبونسر شيب بتاعتنا. هم ده السبونسرز، هم كانوا سبونسرز للميتينجز السابقه وسبونسرز للميتينج الحالي، وان شاء الله حيكونوا سبونسرز للميتينجز. فنشكرهم جدا على تعاونهم ووقفتهم القويه جدا مع اس دي نوج. طيب، نظرا لانه قلنا الاجتماع حيكون عباره عن ساعتين، فنحن حنسجله لانه بنتوقع ان الناس ما كلها هيكون عندها انترنت اكسس. في ناس ممكن الزمن يكون ما مناسب معاها، فحيتسجل وحيتبث ان شاء الله في قناتنا على اليوتيوب اللي هي youtube.com/SudanNOG. ففي اي زمن ممكن تشاهدوا الفيديو ده، هو على اليوتيوب حيكون افيلبل لكل الناس. بعد ذاك لو الناس عندها اي اسئله، الناس اللي حتشاهد لاحقا يعني ما حيكونوا معانا لايف الان، لو عندها اي اسئله ممكن تسال على الكومنتس ان شاء الله، وحنحاول نجاوب على الاسئله بتاعتهم ان شاء الله في السكشن بتاع الكومنتس، او ممكن الناس ترسل ايميل بالاسئله بتاعتها، وبعد ذاك ان شاء الله تتم الاجابه على الاسئله. طيب، في الزوم سيشن حاليا بنطلب من الناس انه الميكروفون بتاعك يكون ميوتد. لو اي شخص عنده سؤال مثلا حيكون في الكيو ان اي سيكشن اللي هي في الشات سيكشن، ممكن تعمل بوست للسؤال بتاعك، وان شاء الله حنجاوب عليه خلال السيشن بتاع اليوم. زي ما قلنا ما حيكون في تكنيكال فولو اب للامبلمنتيشن بتاعك، لكن حتكون اسئله عامه. لو عندك اي داوتس عن الامبلمنتيشن الكونسبتس كده، دي حتم الاجابه عليها هنا. لو لاحقا مثلا حصلت لك اي مشكله اثناء الامبلمنتيشن او اثناء انت بتشاهد الفيديو اونلاين على اليوتيوب، ف دي اللي هي قلنا حنشيل الاسئله من الكومنتس على اليوتيوب او الاسئله عبر الايميل. طيب، لو امكن الناس عملت تيرن اون للفيديو بتاعها بس عشان نشاهد الفيسز. دايما الناس بتطلب انه تشوف الناس قدامها. المشكله بتاعت الفيرتشوال ميتينجز انه الناس ما بتشاهد بعض، فبتحس بانك بتتكلم براك كده مرات. فعشان كده لو قدرنا يا شباب نخلي الناس، يعني لو الناس بتقدر ممكن تشير الفيديو بتاعها، يعني على اساس انه يكون في انتر اكشن، يكون في فيلينج بانه الانسان ده بيتكلم مع الشباب ده. واهم شيء برضو لازم الناس تسال الاسئله بتاعتنا، لازم الناس تسال سواء كان عربي او انجليزي. لو عندك اي داوتس، اي سؤال، اي مفهوم ما واضح، لابد من الناس تسال يا شباب، لانه الهدف الاساسي انه نحن نعرف اكثر عن how to build a cloud infrastructure. طيب دي اللي هي عبارة عن الأسئلة بتاعتنا دي السلايد ده. طيب في طلب تاني منكم، لو الناس ما عندها مانع برضو، حاجة بتشجعنا جدا وبتثبت يعني وجودنا اونلاين، لو الشباب عملوا صورة، يعني اي واحد اخذ صورة وهو بيحضر في الاجتماع بتاع SdNOG اونلاين ونشرها بالهاشتاج الموجود امامكم، يعني virtual_SdNOG-7. على الهاشتاج ده يا شباب، لو يا ريت لو الناس اللي بتحضر في SdNOG تاخد صورة بس من هي بتشاهد المؤتمر بتاع SdNOG، وتعمل لها بوست، سواء كان على فيسبوك سواء كان على تويتر. ده اللي هو بنستفيد منها في فليكر ان شاء الله، عشان نثبت وجودنا ومشاركتنا وتفاعلنا مع المؤتمر، وده بيشجعنا ان شاء الله انه نعمل ميتينجز لقدام اونلاين كثيره، ورك شوبس اونلاين، وعشان الناس تستفيد اكثر برضه. يعني الموضوع ده بيعني لنا كثير جدا، فيا ريت الناس تشاركنا بالصور بتاعتها بانها هي بتحضر المؤتمر والتفاعل بتاعها مثلا. طيب برضه عايزين الناس يعني تشارك المؤتمر، تشير المؤتمر، يعني وبعد ذاك يكون مشاركتها فعالة بأنها تسأل أسئلة، ترسل صور مثلا، تعمل شير للمؤتمر بتاع SdNOG في مجموعة من وسائل التواصل المختلفة. عندنا في نهاية المؤتمر عندنا سيرفي إن شاء الله هنعمله، وعندنا جيفتس، يعني السلايد ده كان بيتكلم عن الجيفتس. عندنا هدايا قيمة إن شاء الله هنقدمها بعد المؤتمر للناس المشاركين في المؤتمر بتاعنا. الهدايا حيكون في زي بول، الناس حيتم الاختيار عشوائيا من الناس بعد الناس تملى السيرفي بتاعنا. السيرفي هو عن الفيدباك يعني بتاعك انت عن الورشه، الليرنينج اوتكمز بتاعتك انت، والباك جراوند، بعض المعلومات الاساسيه. السيرفي ما بياخد دقيقه ونص كده. ف السيرفي هو فيه فيدباك بالنسبه لنا نحن، عشان كيف نحسن من الاداء بتاعنا والمؤتمر والورك شوبس القادمه وكده. في نفس الوقت نحصر الناس اللي حضروا المؤتمر، وان شاء الله الناس دي حتكون هي جزء من المشاركين اللي حيتم سحب الفائزين منهم ان شاء الله. طيب الانستراكتور بتاعنا الليله حيكون داني هو مشهور جدا في المجال بتاع التك في في افريقيا، وهو هسه حاليا في اوروبا. فداني عمل هو ك نتورك اركيتكت وكلاود انفراستراكشر، وهو كان سينيور كلاود انفراستراكشر كونسلتنت في ريد هات كوربوريشن. انا من هنا ما هتكلم كثير ان شاء الله، بس زي ما قلت لكم لو عندكم اسئله ان شاء الله اعملوا لها بوست في الشات. عندنا I'll hand the floor to Danny. Danny, you can share your screen please.
Hello, can you see my screen? Okay, I think we are good. Hold up. Yeah, I would like to thank you. It is an honor to be here in this virtual Sudan NOG, and it is an honor to present the cloud computing. And my name is Daniel Fonko. I'm a senior cloud architect. I work like a consultant for 18 years experience in the cloud computing. I worked for 4 years for Afrinic as a network engineer before I moved to France. I'm based in France, where I work with Red Hat, like a senior consultant in the cloud architecture. I've created my own company after that for building what I call a cloud for Africa. And I'm developing a tool that will help to build cloud infrastructure in Africa region. I will have the opportunity to show you more about this project later on. And my expertise in the cloud computing is to give you in this tutorial the background of how can we build a cloud computing from scratch on machine on premises, because this is the idea. Because for me, building a cloud infrastructure is not about using existing cloud infrastructure like Amazon, Google, or Azure. Is like you are only consuming a service. But the idea of this tutorial is to give you all the tooling to help you build your own cloud architecture, cloud infrastructure. So how are we going to do that? We are going to go through some different items, some different topics, some different mind shift to give you all the tooling and all the reflection, all the idea that you need to make such things happen. When people are talking about the cloud computing, about building a cloud, most of the time people are thinking about something very far. People are thinking as it is in the cloud. Not, it is again on your computer, it is on your machine, but it is the way you are designing your cloud infrastructure that will change the what you are offering, like a cloud solutions. So if you have a question, we will go through the different topic that will help you to understand exactly what, when we are talking about cloud, what is it really about? And we are going to first to talk about the DevOps and the agility. And one of the most important things is it will be infrastructure as a code. We are going to talk about a source control versioning, like a Git, and how are we going to use the Git flow. And then one thing also will be important, it will be the CI/CD pipelines for the continuous integration and continuous delivery automation with containers and Kubernetes. We are going to talk about microservices and what is really API, and we are going to look at how Ansible works. So if you have a question, do not hesitate. You can leave your comment or your question using the Q&A, and Mohammed will take all those questions after after every chapter, and then we will go through it, and we will I will try to answer to all your questions, all to your inquiries as I can. So if you are ready, I'm ready. So let's go. What is DevOps and agility? What is agile? Agile, it is the methodology, and this methodology involves continuous iteration of development and testing, and in the software life process. This is the methodology used in mostly when we are designing a software. Instead of having a big huge of code that you will write from the beginning to the end, and after testing it, the idea is to break your code in small pieces, and then you test and you review all those small pieces of your code to make sure that they are working. And then by adding your code by strat, small pieces by small pieces, afterward we will have a big code with all the items tested and working. So this is the methodology, and this methodology is kind of like a common sense methodology nowadays for everyone. So it is this way of doing code that people will call in different ways, Scrum, Kanban, and use those funny words, but those are quite important. Then when you are talking about agility, agile, what is it really about? So when we have your customer and your developer, those are the two components of resulting a product. Is like your customer will request for you to design or to do a project or to do something, and then you have on the other hand your developer who will be responsible of coding and make this project happen. So the agility will use a kind of will facilitate the bridge in between those two actors, and the developer and the customer. So what will be like, the customer will do what we call a requirement, and then based on the requirement, the developer will do the design, will develop, will test, and then he will deploy, and then he will review and to make sure that it's working. And then he will ask to the customer, are you okay with that? He will say, yes, I'm okay with that. And then we move to the next action. So instead of having a big code, we will break down this code in small pieces. And then people will ask, what I'm going to develop, what are we going to do? The developer will do the process, go through all this process again, in between requirement, design, developing, testing, deploy, and we make the customer review the code and then review the result. And then if it is okay, and then this action is done and we move to the next one. So this is what we are going to call the minimum viable product. And then people are also talking about DevOps. So in many job opportunity, you will have people will ask you, yeah, are you DevOps engineer? Are you DevOps architect? DevOps again, DevOps. And again, DevOps is the methodology. It's not let's say, it's not a function. It is a methodology. So people who are saying we are looking for DevOps, it is again, it is wrong. It's wrong. People need to say we are looking for engineers who have DevOps skills. You see, and then the DevOps is a methodology that will help you to focus the integration between and the collaboration between professional and make rapid deployment of the products. So the DevOps, it is a culture that will promote the collaboration between the development and the operation team. So you have those teams that need to work as well together to make something happen. So when you have your code with your agility, and then you have your code ready, so how are you going to implement your code inside your network or inside your infrastructure? So you need something that will speed up or make this bridge between now your code and your operational process. So this is where the DevOps culture comes in. So DevOps culture will be the one that will make this bridge between those two environments and make your code ready, fast in production. And then if there's a bug or if there's an issue, how this code can be reviewed and fixed and make and push back to the production again without losing too much time, because time is money. Time can, if you have a buggy code in production, that can lead to a lot of, unintended issue. So it's something need to be addressed as fast as possible. So those are small item. It's like the DevOps will be addressing the gaps between the developer and the operational team. So how are we going to move from the code? So you have first, your code is built. it is the I don't know if you are seeing my screen. The tip, it's built, and then your code will go through. Let's take it. I mean, first you plan your code. You plan, and then you do your coding, and then once your code is ready, is you are building it, and then once built, you test your code first, and then once your code is tested, the developer side is over. So now it comes to the operational part. The operational part will release your code, will deploy it, will run it, and then will monitor to make sure that everything is working fine and there's no issue. And then if there's also a new release of the code, again, the developer will plan the new release, will do the coding, will build it, will test it, and then once it's done, comes to the operational part that will release, deploy, operate, and monitor. So this is an infinite loop where the operational and the developer are working together. So the IT world is changing. I would like to say has changed a lot, and this COVID-19 threat and is changing very fast and changing quickly again the IT transformation. So now we are now in virtual. Normally we should be on site, but now we are virtual. So it is changing very, very fast. We need to now to look at what will be now the time to market. What will be the time for us to quickly design something and to be operational at the same time as fast as possible. It's something that we need to definitely look at in the current business. How flexible are we in term of challenges, in terms of new constraint, in terms of new policies and new threat? How flexible are we? Again, what is also important is the cost. Whatever we have to do now need to be set in the budget, in the cost, because now again we are going to a worldwide crisis and we need to be ready. And the money is capital, is crucial for a development, for any kind of business we want to run. And it's also important to look at what will be the best cost in the process. The competitivity, how are we going to be first, doing what the other can't do, and be one on the market first, is also important. So if you look at all those challenges, the traditional way of working cannot fit. It cannot fit at all. So we need to change, to go to a new business model that will speed up all those challenges and at least try to eliminate if what they can eliminate, or if they can improve or or reduce that much all those burden. So the agility will replace what we call the waterfall methodology in developer world. The development culture will define now the new sysadmin and network engineer. And then we have all those actors. The developers are changing, the operational teams are changing, the actors are changing. But what about the infrastructure itself? It is something we really need to look at. How can we design an infrastructure that can hold, or that can be flexible as possible to handle all those changing that are happening in between the developers and the operational and the sysadmin and the network engineer? How the infrastructure itself can be flexible. Do you have question? If you don't, let me see if there's a question. Mohammed?
Yes, actually, there is one question.
Yes.
Uh, do developers must have the skills to do deployment phase?
Okay. Yeah.
Like,
Yeah.
yeah,
Yeah.
for
Yeah.
for for
Yeah.
developers, like, is it important to have some skills for the deployment, or they can just deploy the code? I mean, that is how I understood the question.
Okay. And that's it. I don't. After that are the two after questions. It is only this question.
Yeah, it's just this question
Okay. Perfect.
for now.
Yeah. Again, it is matter of skills. I will try to answer as closer as I can. It's a matter of only of question of skills. If your skills that enables you to even go to production with your code, yeah, why not? And again, it is matter of not only of skills, but also matter of policies inside your enterprise. In many enterprise, you have different level of responsibilities. You have the developer who is only responsible of doing the code, and that's it. You have the operational team who is doing the operational, and that's it. But now with the DevOps, those two teams need to work together. So the developer knows a bit or even all about the operational part. The operational also have a good understanding of the coding, as well how the code is written and how it works. And then when you have those two teams working together, you have a kind of, they are sharing knowledge, they are sharing skills, they are sharing competencies, and then they can work together. So as developer, your final goal in this new era of from cloud-based infrastructure, you need to be able to go to production. So yes, it is important for you to know at least a bit, or even all the steps that need to for you to go in production. So you need to be a fully skills, or at least to know exactly how what need to be done if you want to go to production. Yeah, I think I guess I've responded to the question. Now I would like to also to talk about something, and then about what we are going to call infrastructure as code. And then after that, you will see how all things are going to link together. So this is the idea first. So when you are talking about infrastructure as code, it is about uh, provide provisioning a human readable code for a system for the administrator, even not the only administrator, for someone else with less skills to be able to read, understand what is it really about. If I want to make myself more clear, is I'm not a network engineer, but I should be able to read a code, at least to understand what all those commands in your code is working. Uh, it is a way to simplify the code and make it human readable instead of having all the comments straightforward one after the another. The idea is to have your code readable, and then from that I can read, I can amend it, I can give my opinion, I can give my comment and say, okay, yeah, here is not the right way, can we do it that way? So why is it important to have something that will abstract the final coding from from the on the user perspective. Why is it important? It's important for one reason. Again, when we are talking about when we talk about the DevOps, you can see that we have the developer and the operational team are working together. But now, if you are going to the infrastructure as code, it's not only matter of one person in his corner doing the code and say, okay, now I'm automating all the process. It's a matter of integrating all the different teams together. And how can I make sure that I have a common language for all of us to be able to understand and to be able to contribute and be able to amend without forcing someone to learn how my coding is working? Is to have a common language that we can all share, we can all understand, and we say, okay, this is how are we going to implement our infrastructure. We describe our infrastructure like a documentation. This documentation we are sharing, or documentation, each patches, holding a part of the infrastructure, we take this part of the documentation and we understand and say, okay, yes, this is where we are going. This is how we can, we are working. And if I want to add something and I have a big picture, a overall view of the entire system, and I can amend, I can contribute. And this is one item I would like to stress I would like to stress is when we are doing the cloud computing, it is a culture the entire company need to adapt. You need to make everyone, approving and to be part of the process. So this is something very important. So infrastructure as code is not only about automation. It is more than automation. It is a way to make a script or a coding, a documentation transverse. I might not know how your Juniper code looks like, but I can read your documentation on your Juniper code because we are going to share the same language, the same way of configuring. So this is what infrastructure as code is trying to address, how we can have an abstraction of the code and make sure that the code can be now used like the same way we are using the coding. So we can roll back our documentation, we can apply our documentation, and we can amend our documentation. And then once we amend our documentation, our final code, our final infrastructure will behave accordingly based on the what we have set in the function or in the process of our coding. So if you look at toolings like Ansible, Puppet, Terraform, or Chef, or Salt, those tools are like infrastructure as code because you have a kind of a formatting, a way of read to write, a way of writing the code, and then the code will apply on a target. This target can be a virtual machine, can be an equipment, network equipment, or can be a process, and then this process will behave accordingly to the state or according to what has been expressed in your code. I can say, I would like to install, for instance, a web server. And then to install a web server, it can be something I say, install a web server. I can say where on the virtual machine at this IP address. That's it. And then if you have this code, I can understand that, okay, this is about installing a web server at this location. If I give it to someone who have no idea about the network engineer process, he will also know that what I just say is installing a web server at this location. How the system will operate in the background to make it happen, I don't want to know, but I can at least tell to my team all the action or all the states that are that will impact my infrastructure or my services or my application or my processes. So it is important to have um, uh, this mindset. Let's call it this way. This mindset, it is important. So now, when we are talking about infrastructure as code, we have an environment accessible for everyone with a basic knowledge to know all the coding techniques and structure. This is what I call a big paradigm shift. It is important to have this in mind. Now, to build a cloud infrastructure, you don't need to be now an expert to do that. So you can, everyone can understand exactly what is it really about, to have a big picture. And then from there, you can go into the details to make it happen. So this is what changed really in this way of thinking. So we are adding complexity, but again, we are saying that now the code is more readable, more easy to understand. So this is the complex. This is the paradox we are trying to pinpoint. To design a best infrastructure as code, what will be the item that we need to take into account? Now our infrastructure is like a code, because we are using infrastructure as code. All our routers, switches, virtual machine, application, everything we have in our network, in our infrastructure now is a code. So how are we going to make sure that our code is maintained, can evolve, or can be amended without losing the track? We need to take into account something that we call a code versioning platform or application that now can, take all our changes and make it, we can track all the changes that we are making in our code. That's why it is important to have a software like a Git, like SVN, like a Mercurial, like there are many to control your code. You need also to do what we are going to call the testing for your new release. Again, the same way you are doing your coding. So I'm doing my coding. So every time when I make a changes, these changes need to go into the process of testing the changes and make sure that I'm not putting something wrong in my code. And if there's something wrong, I need to be alert automatically so I can prevent a system outage, because it is status before going to production. This is what will also help to avoid documentation. One of the big items I would like to stress out is people are saying, even me, I've taught a lot during my SdNOG meetings, document. But again, it is very hard. It is extremely hard to document your infrastructure. Why? You are fighting with the production and you need to do some improvement, and you have the consultant who want to implement a new code or a new extension, and then you have to document all those. Sometimes it's challenging, it's extremely challenging. And then have an accurate documentation up to date at any time of your infrastructure uh, can be extremely hard. This is what Infra as Code will now help uh, uh, to cut off. So instead of spending too much time in documenting your infrastructure, your implementation, you are going now to do the process in the other way. The other way, what does it mean? I document my infrastructure and then it is applied to my system. You shift now the burden of implementing and now trying to document and have your accurate documentation. Now we are going to say, I'm documenting, and then the documentation is applying to my code, to my infrastructure. So we are doing it other way, not implementing and now trying to document. We are doing it, we document, and then it is applied. By doing that, what does it mean? Once it's documented, it's fine. And then our system should look like what our documentation is, is saying. So it reduces a lot of work, a lot of burden, again, in production. It will help also the collaboration around the infrastructure and make everyone, part of the changes, part of the process, part of the, the project itself. Do you have any question? Because this part is also is important. Do you have any question? Mohammed, do you have
There
questions?
are no questions
No question.
so far. I think you can proceed.
Okay, yeah. So now let's go. We talk about the Git and the Git flow. We talk about the coding and our infrastructure as code that will help to take into account our changes, our updates, our changes. Now we are going to look at one tool of the source control version. It can be SVN, it can be Mercure, it can be whatever you want to to use. But today we are going to learn the most popular one, the Git, and the process of the Git, what we call the Git flow. So the Git is an open source tool distributed version designed to handle a small to very large project with speed and efficiency. Here is what we call a Git flow. The arrow is going from the right to the left. So the timeline is other way. It's not from the left to the right. It's from the right to the left. And you can change it either way. It's still the same process. What this timeline will look like? The timeline will represent the life of your code. You have your code where the developer, all those engineers have written, and you have your code. Once you have your code, you have to release it. So when you release your code, you need to make sure that I have a running code, I have a running version, and then if there is a change, this change should not impact what I have now, and I can still keep doing my changes and make sure that my changes is working before merging these changes to the current code. This process is well known by developers, but it's also important for the engineers and the operational team to be aware of this process, because it will change drastically the way they are even see their system. So what will be it will be really about? The code is now, the infrastructure is now it is the code. You have the code released in one version, is they say in the let's say in the streamline. And then I can say I would like to have for production another streamline where all the codes on this streamline are only for the production. I would like to say if there is a bug, if there's a fix I would like to solve, I would like to have another line where all the changes that will try to fix a bug will be released on this line. It's only a way of organizing your way of working. And then once you have all those different streamline available, you release your code based on your policies. You can go to production. So once you have you are on production, your code is on production, and then you push it to your machine, to your application, to your virtual machine, and it's working. But now, if there's a change, what are going to happen? Your change cannot be pushed automatically into production. If there's a bug, if there's something you are not aware of, if there's something not well tested, you are going to break your system. So if there's a change, this change, instead of going to production, will go onto into the branch, the streamline of what we are going to call a branch for your hotfix. This is where you are going to deploy your code and make sure that it is working. Once you have that and it is tested and it's working like expected, I can say now I would like to merge these changes to production. Again, you come back to your change manual, your change process, and then you merge your bug fix to your production. Now, because you are merging it and because you have tested it, of course, what you have merged will work because it has been tested and validated. And then once you have that, finally your code will work, because the idea is to be able to have what we are going to call a predictable behavior. So I would like to predict all the process in my network, in my application. I would like to have something predictable. Once I've defined my structure and it is well documented, well tested, the final result will be either success or fail. And I would like to be able to predict what is going to happen. So if it's, for instance, something failed, of course, I cannot merge it to my production because it has been failed in testing. Of course, it will fail as well in production. There's no magical, situation over there. So the same way you design your flow and your way of organizing your different processes is the same way you are going to have, your Git flow streamline with what we are going to call branch or branches, and then you have. But we'll go into details in the hands-on part later on. So this is the way you have your your code organized. We have our code that can move in between different branches. And I've talked about testing the code and make sure that it's working. People will say, why is it important to have the this testing period or this testing mechanism? It is important. It is a common sense. I've changed my code. I want to make sure that it's working before I push it to production. But if there's a lot of changes, how can I make sure that I cannot, I shouldn't, I will not, take all my team, all my developers to test every single piece of code before going to production? This is not doable. The idea is to be able to test million or billion of code automatically without the human intervention. So if a developer make a changes or an update of a code, instead of having this same developer doing all the testing, normally all the process of the testing, validation, and reviewing need to be done automatically through a pipeline. And this pipeline will be the automated version of your code. Once you release your code, it will go through, it will be taken into account by the pipeline system, what we're going to call the CI/CD. CI is for the continuous integration, to test your code, make sure that everything you have before is still working, and then what you are supposed to fix is not breaking something else. Then once you have that, it will help you to make sure that I'm putting a new code, but I'm not breaking something else, to avoid what we call the non-regression process or the non-regression code. And then I can only improve a code. I cannot, break previous one. And then it should be done automatically. Once it is tested, review, and is ready, this is what I call the continuous integration. That's the first part of the process. Once we have that, it's not done yet, because the code seems like it's clean, is working, but I will not call my operational guy and say, okay, now we have released a new code. Can you try to see if it is, if you can push it to production or to push it to the testing environment to see if it's behaving properly? This process also need to be done automatically. This is what we are going to call the continuous deployment. And then once you have your code ready, the operational part of what you call the DevOps, the code will be deployed automatically on the production or pre-prod or the testing environment by another tooling process. Your code, it will be published, and then the engineer will only see the result and see, okay, my code is working and everything is working like expected. And then for sure you have your running code tested, validated, and working. And then I can say later on, I want to push it automatically to production, even if I do not recommend to do the automated push into production. I do not recommend it at all. I would like to be responsible of pushing the code to production for many reasons of security, of control, there are many reasons, but this is my personal attitude or my personal responsibility. But in many companies, in some companies, you have the production release that is also automated, because if you have strong pipelines, and they are well documented and they are working expected, yeah, again, you have this predictable state or predictable situation where once you release your code, if your code is not breaking, it can go to production automatically because it is designed the same, designed this way. Then, for instance, if you have the pipeline for a GitLab, you will have your code from the left to the right. You have your code. Once you committed your code, you have your changes, you have your rated code, you merge all of this. And then once you have that, it will go through a pipeline. You can see the pipeline of building, of testing, and doing all the integration. And then all those integration is done by the Git and a Docker. Can be something else as well. And then once you have this part already okay, successful, it moves to what we are going to call the deployment part. Then your code is reviewed. It will push into staging to make sure that everything is working as expected. And then if nothing breaks and everything is working as what you have stated, this code can move to production. And then you have the CD, the continuous delivery pipeline with GitLab and Ansible. And yeah, let's see if you have questions.
Yes, we have some questions here. I'll start by the documentation one. Is the documentation for the code itself or just for the changes that we are going to do the code? Yeah.
Okay, yeah, the documentation is about the infrastructure itself. It is only about the infrastructure itself. And again, your changes will appear in the tool, like in the Git difference, because your code now is your infrastructure now is the code. And then if I do a changes, this change will be reflected automatically. It's like you have your code of Apache or PHP, and then there's a bug in your code. You remove a part or you fix a part of your code. You see, the same way your infrastructure will look like this. You can change an IP address of your router. You can change a name of an interface. And then once you are doing that, the system will say, okay, there's a change at this level, and you can keep the track of your changes. If you want to roll back, you can roll back easily to the previous state, or you can move to the next, to the, you can apply directly the changes or the current state of your code, because you are keeping all the track. This is why it is important to have such a tool like a Git, a versioning tool to help you identifying what has changed, what has been added, what has been removed, for you to not be forced to do the documentation of your changes. But again, the documentation of your changes is also important. In which way? In a way where whatever you are doing, you need to state it clearly. It's like you want to say, okay, you have your code ready, and for instance, there's a bug in your code, and you want to change the IP address, you want to change the router ACL on your router to enforce a policy. Once you have done all the changes and make your code look good again after applying all those changes, there's a part where you are going to call the comment, and we say, and then this is where you are going to tell exactly what your changes is really about. and then we say, okay, there's a bug at this level, or there's a ticket address. There's a ticket uh, telling there's an issue somewhere, and then this is how I'm going to fix it. This is how I fix it. This is how the changes is done, and then you write, you document, you tell exactly what is it agree about, what you have done, and for what purpose. And then once you have that, I can see from the Git, point of view, that this is the current version of the code. This is what you have uh, amended and updated, and I can see what has been removed or what has been added. And if that match with the description or what you are trying to address, I can say, yes, it is okay. This code can fix our issue because this is the right way of doing it. And then you apply it or you merge it to production. And again, what is also important, you can see the pipelines the uh, of the Git. Those responsibilities need to be separated. So it is, of course, only one 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 developer or one engineer or one ops can do all the steps. But it's important in production or in the company to have different responsibilities. Once you have all those changes updated, testing, deployment to the staging, at least going to production need to be, if you want to, if it's not done automatically, need to be under a responsibility of one or two or three person that will approve all those changes and say that, okay, these changes has been approved by all the, at least two of three of all privileged people are allowed to push the code in production. Once you have that, it's sure that you have the majority of the people accepting the changes, and then the change can go to the production because it is done, it is reviewed by one, confirmed by the second one, and then once it's okay, we can say the code can go in production. Again, it's also a matter of policies. How are you going to validate all the changes for the production? It's only you that need to decide how strong or how flexible you are in your infrastructure.
Yes, thanks, Danny. We also have like two questions related to agile methodology.
Yeah.
Like if we adopt the agile methodology to develop a system, is it true that the iterations can be used to control and document the published versions of that system?
The iteration can be
Can be used to control and document the published versions of that system, like if we adopt the agile to develop a system.
uh, e- yeah, the agile is a methodology, and this methodology is only about uh, doing a small iteration of releasing the code. It's giving the flexibility, and is the agile will help you to document, uh, not necessarily, but the agile is important in your way of documenting your system. So the agility will be the way of doing your documentation, for instance. So you have your infrastructure as code, and then instead of doing the changes, for instance, in the we have a bug in the firewalling, in the IP address and the name, for instance, and we want to address all those three situation or three issues. In the agile mode, we are going to take all those trees separately. First, the firewall, second, the naming, and third, the IP address, right? And this is where the agility will comes in. Instead of having one big change that we take into account all those three, we have three small pieces of changes that we address the firewall. One we address the IP, and the third one we address the host name or the naming. This is the way the agility can help you documenting very well and make sure that your code is going to the point, and then you can revert if there's an issue, instead of having your big huge of changes that will take into account many changes, and where you don't know what exactly has changed, what is impacting where, and then yeah, agility will only a way of helping you to better address your documentation, if you want to say that. I mean this way.
Okay, and there is also a follow-up question to that. Can the agile be adopted with the legacy development process, such as waterfall and a spiral model, or is it a standalone model?
Yeah, the agility can comes into at any time in the way of coding, and again, the previous version way of coding need to be reviewed and need to be addressed somehow. And you can start again. It's not, if it is only one person, he can change his behavior and do whatever he want to do and change maybe his way of working. And if it's a team, you need to spread this culture across your team and make sure that the team is working at the unison. I mean, in the same way. You cannot be alone working in the agile methodology in your corner, and have the rest of the team working in the waterfall. Is not compatible. Again, it's a matter of working together. If it is you only one, you can do your changes, your transformation, and start adopting a new way of coding by using agility, Scrum, Kanban, and all those methodology that I've stated before. Or if it's a team, you need to make sure that all your team is trained or is aware of new way of coding, and this way you need to move all your fellows, your colleagues to that.
Okay, there's a question related to infrastructure. Do I have to imagine my infrastructure flow at first? And then, as we know, some editions will assume while we are in testing our code, and that what if we would like to let the code as it is, and we would like to make our edit outside and push the change without affecting the data that we are
Yeah.
entered before. Is that easy on get or get flow?
Yes. Yes. This is extremely a good point. And before going to coding, all of us in our subconscious, in our imagination, we have an idea of how we're going to design our infrastructure. Somehow, we have all this final infrastructure in head. Even if it's not written, we have it in head somewhere, saying that this is what we are going to do. Otherwise, if you come to on your computer, there's nothing to do. You don't. If there's no vision of no target, you can't do exactly what is it what we are mission to to do. We all have this idea of your code, of your infrastructure in head, and this is why the infrastructure as code is important. It will help you now to start imagine drawing your network or your infrastructure first, and then start building it the same way. By doing the infrastructure as code, you can have your infrastructure well documented, and now it will be applied automatically. But again, it requires some skills and some knowledge first, and the knowledge of having a way of doing the abstraction first, to be, disconnected to the final infrastructure and design. This is where comes in the skills of architect that will, design all the system, the infrastructure for you to be able to operate it properly and have this way of working, have this flexibility later on. But again, all those skills are now converging together. So the DevOps will now become more and more close to the architect, and the architect will be more and more doing a lot of DevOps, skills and DevOps approach, doing all those deployment as well. So all those skills are conversion are trying to converge together. And yeah.
Okay. Yes, I think
That's
this
the
how
question.
yeah. So can
Do
proceed.
we have much time or yeah, I think it's okay.
Yeah, we can just finish maybe the theoretical parts and then we can take a break.
Yeah.
Um,
Okay.
Yeah.
So as you can see in the pipeline, we talk about the Docker, isn't it? And then what is Docker? Here we can see we have Docker, we have Ansible, and what Docker is doing in our testing in our testing environment. Why do we need Docker? Docker will so first, let's look at what is Docker. Do I need the Docker or in my system? Why it is important? The importance of doing the Docker will be to facilitate all the testing part. How? It will be able to provide a kind of identical environment to the production, but with less money. In the perfect world, if you are a network engineer, I want to say in the perfect world, if you are a network engineer and you want to run a big infrastructure of routers, of switch, of the core network and your application, to make sure that all the code you are releasing are tested and are working correctly, you need to have identical environment across your infrastructure. So you need to have in production your infrastructure that need to be exposed to your customer or your team. And then for the staging, you need to have the same infrastructure again over there. And then for the testing, you need to have the same infrastructure as well. By doing that, what does it mean? If the production environment is costing, let's say, 1,000 euro, in the staging, you need to spend again 1,000 euro as well in the staging, in the testing. And then if you have different environment, you need to spend the same amount of money. That is not doable. Some companies are doing it, but they have a lot of money. But in the most of the companies, that's why I say in the perfect world, this is how things need to be set. But in our environment, there's no way to do certain things. If you go to your financial manager and say that, hey, we need to address this. Say it again. Yeah, if you go to your financial manager and say, yeah, we need to spend the same amount of money in the production as well as the development environment as well as the staging, and this we need to triple our budget, he will say definitely no. There's no way for you to do that. That's why we comes in the idea of Docker. The Docker will help you to replicate, to have the isolation, the not they have isolation and the identical environment across different environment, but at lower cost. And then once you have that, Docker will emulate your different environment. It's like a virtualization, but not for the hardware, but for application. If I want to be root in the explanation. So the Docker will be what we are going to call the isolation software that will help you to standardize your unit of development and to be able to shift and deploy the same way. All the coding, all the system will give what we are going to call will give all the libraries for your application to run in the environment that will fit or that will look like the real environment or the virtualized or virtualized environment, but it will be only for applications. If I want to make myself more clear, the Docker will be a way of creating isolation environment where all the libraries will be enabled, activated for your application to run properly, and then without interacting with the underlying kernel or without interacting with the underlying platform. By doing that, we can have a standard way of deploying, of using our infrastructure. It's lightweight, it is extremely lightweight, and it is secure because it is isolated. Even if the perfect isolation is not true, but is using the tools like mechanisms like a C group and jail and SdLinux in some systems to jail properly all the process, to make sure that the process is not allowed to go beyond what it's supposed to do. Those are, security mechanism. So what will be the difference between the virtual machine and the container? If you look on the right, yeah, this is the right, you have the virtual machines over there. So you have what will make a virtual machine works. We are going to call it an hypervisor. So the hypervisor will provide all the hardware abstractions for your machine on the top of it to be able to have the same look and feeling like a dedicated machine. The hypervisor will provide the network, the storage, the memory, the CPU for the application, let's say, for the virtual machine to have the same look and feeling that it is a standalone application with different resources. So if we ship this way of thinking to application, we have what we call, a Docker engine. that will provide the same, let's say the same capability, but for applications. If that's the case, we can have virtual machine, we can have physical machine that will host virtual machine using an hypervisor, and this virtual machine will host a Docker engine that will host containers, right? So yeah, we talk about the container. And then people also talk about a Kubernetes. What is the Kubernetes? The Kubernetes will be I would like to say it will be the controller of containers. Once you are deploying the containers, there's a way for you to manage all the containers, to control them across different machines. Because again, I told you we can have containers in the virtual machine itself in the physical on physical machine. And then if you are running a lot of containers, you can come up with an astronomical number of containers to manage. So to do that, you need to have a kind of a controller that will regulate and tell if this container is allowed uh, to communicate, allow this one is allowed comes up, or if, for instance, a physical machine is not available or virtual machine is not available, how are we going to manage all the containers on this machine on another platform? How those containers can migrate automatically? How those containers can be respawned elsewhere? This is what the Kubernetes will try to solve. The way of maintaining, controlling a large scale of containers. And this project is released by Google in 2014. And since then, in the battle of containers management, Kubernetes is the winner. We have also Mesos. We have also I forgot the name of this pivotal of yeah, those are there. There were many pivotal and Mesos and Kubernetes. Those are the one who are the beginning fighting to have the best tool to manage and control the containers. But Kubernetes won this battle because of its openness and the community behind. And yeah, this project beats all those, and now almost all the containers environment are driven by Kubernetes. Almost all of them. Then comes in what we are going to call again API. API is not something new in our environment, but it's also important to pinpoint. API, for many reasons, we also know there's like application program interface. People are saying API for a while, but now API is crucial in this ecosystem. Why? Because it will give ability to talk, to do the kind of a bridging or communication between the different entities. But we'll come again about to it to see why is it so important to have API ready. So API will be an interface that will receive a quite of questions like HTTP mostly, HTTPS to be more secure, and the action will be post, get, put, delete, and yeah, so the basic HTML request. And then behind we'll have what will happen to do such a thing. If I use a get is to retrieve information. I would like to get something. If I want to put the action is to commit or to change something. And if I want to delete, again, it is for removal, for deletion. And then if I post something, I would like to do an action to update something. And then yeah, this is how the API will look like and will behave, receiving information and then uh, 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 and then receive information and then uh, sending back the response. In microservices will be uh, it's will be in opposition of monolithic. Why are we talking about microservices now? Again, if you do remember at the beginning, we are talking about the agility where you have your code written and you split your code in small pieces, right? And when it comes into services, instead of having one big and huge machine offering all the services, to make it more compliant, it will be to split all this big architecture in small pieces. And then each pieces can be changed, updated, and replaced if there's a need to, instead of having the big, huge of service of a machine offering all the services. And if something is not right, or if we need to update a library somewhere, we need to shut down all the entire system, even if what we are going to change is not really related to the to a service that we are offering to someone else. For instance, you have a huge server where you have your web server, your domain name server, your NTP server, you have your payment gateway, you have your accounting, and all those are working together, and it's fine. Everything is working perfectly. And for a reason, there's a bug in one of a library you want to change, and this library is kind of crucial. And let's say you want to change a PHP library, and then oops, then you realize that okay, changing this library requires for you to change to update the kernel. Okay, can I update the kernel? Yes, but if I update the kernel, I cannot run my HR application or my billing application anymore because those applications are bonded to the kernel that I have. Okay, what can I do? Can I try to update my HR application and my billing application? Yes, by doing that, they require a new version of code uh, that will impact my DNS server and my NTP server. Wow. So by updating only a PHP where we have an issue, I can find myself going into trouble, from trouble, from trouble, from trouble. At the end, I can mess up completely my entire configuration and have an unstable platform because by doing only one update, it can drive me to a complexity or a headache situation. This is why it's important to separate all those resources in small pieces. Then what will happen then if I break down my big application in small pieces. I would like to say I will now, instead of having this huge machine, still have the huge machine, but inside this huge machine, I would like to split all the services by function. So I have one microservices for my DNS server, one microservices for my billing server, my billing service, my billing application. I have microservices for my accounting, for my NTP, and for my web server, and so forth. By splitting down, by cutting down all those items small by pieces, it will help me if I want to update my NTP server to not be able to force to change all my system because it's not related. And again, using the agility, I can only change what is important or what that need to change and to be reviewed without affecting the existing running code. Again, agility comes into place. If, for instance, one system now needs to talk to another one, now we need to create what we are going to call an API to make sure that they can all talk together without having to breach the security and make sure that, okay, I need to revamp all my code and integrating all those code again. So I create a small or running version of my service, what I call a microservice. And this microservice will be doing only one and single function. And then if I would like to have a big system, a big infrastructure, all those small pieces of function will interact together. We talk to each other to make sure that the entire system is working and is available and working like expected. So if one version of the code is not working, I can change only this library without affecting all the running version of the code that I have. Again, by doing this, what are going to happen is I can have a same version of the code running side to side without changing anything. So I can have two versions of my web server running, and because I can only address one, the second also can run. This is how the containers works like. And then I would like to say, when you are talking about microservices, people are saying, oh, is it really about also, still talking about the infrastructure? I would like to say, yes, it's still about infrastructure we are talking about. Again, when I say we have all the service that we are offering can be chopped in small pieces, where we have each services representing one microservice. Then we have a microservice for the Apache, one microservice for the NTP, one service for the NTP, for DNS, and so forth. And then now, what is important to talk about microservices when now it is about those services? Is not what is it is. People will say, yeah. So after what has changed? This is the way people are doing. They can do virtual machine doing the same, and that's it. Yes, it is the same, but that's not really the idea. The idea is to have something like Kubernetes or a tooling that will help having different version of the code or the application running side to side without breaking the continuity of the business. That's why the containers will comes into the play, where even for the infrastructure services, those services can be managed and run by this orchestration tool like a Kubernetes to have your system spread across your network. And if, for instance, your DNS server is not available somewhere, the orchestrator will be aware that your DNS server is not available, and he will spawn it automatically. So this is the idea of building your infrastructure as a code, or your cloud infrastructure is also about building your infrastructure services that can be available anytime. A cloud infrastructure is like building automated, resilient, and self-healing infrastructure. So that's why it's important to go through all those steps of different toolings that will help you to understand why those tooling are so important, why it is important to have this way of thinking before starting using all those tools. Because the tooling are only a tooling, they are only tooling. It's important to have a big picture of why we are using such a tooling to achieve what. And then by that, you have all the skills that you need to have to now start building your cloud system at your level, and then why not scale up to become a cloud provider. For the next, I will invite you to go to this website, workshop.cloudinspire.africa. This is where we are going to, I'm going to show you all the materials for the hands-on part. And this is, you can register, you will receive a confirmation email, and then you submit and you make it, you make yourself available. I will show you, I will show you how to access the different materials. And yeah, I've also started a project called Africa Cloud, and this Africa Cloud is a community project that I've initiated to build cloud infrastructure in Africa. And yeah, it will be, I will be happy and be honored if you are interested in building cloud infrastructure in Africa. If you want to be part of this project, it is feel free to join. The hold on, I don't know if I can give you the link into the comment. It is fcloud.africa. So if you would like to be part of building cloud infrastructure in Africa, it will be what I call Africa infrastructure for African. And then it will be a project managed by and ruled by Africans. So yeah, it will be good to have such initiative if you would like to be part of this journey of building cloud in Africa. So yeah, we are all invited to contribute or to give your comment, or yeah, to be part of this amazing journey if you would like to. Thank you. So we are going to have so let's have see if there's a questions. If there
yes, actually, we have some very interesting questions, but I think we'll have to take them after the break, because I think it's already more than 1 hour, 1.5 hours. So then we'll have a break for like 5 minutes.
Yeah, let's have a break for 5 minutes, and then we'll
then,
come back here.
Yeah, everyone is going to see what you have just learned in practice. So we have our virtual tea and coffee and some virtual snacks as well. So if you, but this time you have to do it yourself. Yeah. So in 5 minutes we will meet again.
Sure.
Let's say at 1:12:16 we'll meet again to answer these questions and to see what we've learned in practice, the practical side of it. Okay, guys. In 16.
Yeah.
Danny, can you hear me? Danny Muhammad, anybody here?
Hello?
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 Yes, I think it's already time, isn't it?
Yes, it is. 5 minutes left.
5 minutes?
Yes.
So, yes, then let's start by the first question. Welcome back, everyone. Hope you enjoyed the break. Uh, so somebody wants to ask if I'm using a waterfall methodology and the department asked to adopt agile, can I transfer my documentation to the new terminology of agile, or I have to start documenting from the beginning?
Yeah, yeah, this is a quite interesting question. If you have started already something and there's if you have to switch to something else, what you have to do is to you need to maintain at least what you have already exists and is still working. The idea is not to trash exactly what you had before, but now starting adopting a new way of working, and then this is this new way that you need to adapt to what you have like existing code, and again maintain what you have already started, and then for the upcoming changes or upcoming work you need to start doing it in a different manner. So do not trash it everything from and start from scratch, but you need to there's a saying that it is on at the end of the old rope when you build a new one. So yeah, you have to maintaining the operational system. It is your same operational, and then you build a new way of deploying, and then yeah, I think it will be the attitude to adopt, not trash everything. Say that okay, what you have doing before is trash and it's not working, and you need to remove it. No, that's not the purpose. You need to uh, uh, improve by adding a new code to your system. Yeah.
Okay, thanks, Danny. And then we have another question like, can we use VM uh, instead of Docker? And is there any another alternative to Docker?
Yeah. Yeah, you can use VM, you can use virtual machine to do the same way. Again, it's only matter of processes and matter of resources. If you have enough resources to run virtual machine and to be able to achieve the same result, fine. For me, it's quite perfect as well. It is the way you interacting, the way you are working. It is process and what you have on front of like resources. Once you need to combine those two and do the same way of it is uh today we are talking about container, tomorrow can be something else, and this is but your code or your philosophy need to be should not change. If
Okay,
there's
and that's
another alternative to Docker, yes.
Docker.
Nowadays there's a consortium of containers that is taken into place uh, to harmonize all the containers definition. So now on Kubernetes you have uh, the the terminology of pod, like a pod. Pod is a entity that represents a service in Kubernetes, and this pod uh, has a manager called pod manager podman, who is trying to change to replace Docker. You don't need to have the Docker now, because a lot of kernel now integrating all the underlying software of code that will allow you to run your containers directly on your kernel without having the Docker. The Docker was a software that will emulate this abstraction of container. And one of the biggest issue that Docker has is once you have your container on your engine, on a Docker engine, if for instance your Docker engine is compromised or is not working as expected, or has a bug, all the containers on top will crash. But if, for instance, we can make a mechanism for your container not be bound to, let's say, to is an engine, but bound to the kernel, it's more difficult to have the kernel hung, because if that's the case, it is the entire machine who is in the bad situation. But it's hard to have the kernel hung because of of a software. So it's important now to, that's why this way of doing the containerization is taking over the Docker. But again, Docker still exists and it's still working. And now on Red Hat, on CentOS, on Fedora machine, you have the pod for pod, man for manager. And yeah, this is the new way of calling containers in Linux environment, podman, pod, and yeah, all those.
Yes, and then we are using blueprints to build our images that contains the applications to run in the container. How can we scan or guarantee the blueprints it's clean from any threat?
Yeah, this is the blueprint. The way of now depends. Based your blueprint can based on your provider can be set somehow, are defined somehow, and the blueprint is a way of managing your having the best approach of when it comes to the deployment. If you want to investigate and see how the blueprints are designed, there's also a documentation. Normally, when you're using a blueprint, you have the process of how this blueprint is working, and then where the image are being fetched, how they are being patched, and how they are working. And then you need to do what we are going to call a reverse engineering if you don't have the all the mechanism well documented. But mostly when you are using blueprint, it is the same way of doing infra code by compiling all those processes into one action. The action will be what the blueprint of installing or the blueprint of CentOS 7 or Fedora 20 of SQL Server, or a blueprint of a in-house application. So if I want to deploy such application, those are the image that I want to grab. Those are the repository that I want to attach to it. This is the software piece of software I want to run once everything is set and ready. So it is again a process. It is a way of automating all the process, but to the user, instead of say install this first, do this second, do this third, and so forth, you will give him only a blueprint action and say, okay, this is how you are going to do if you want to deploy an application or a software or our in-house application or a CentOS or Fedora or Linux guest machine, whatever. And then this is how it works normally in our side. But again, you only need to trigger one action, and this action will collect all the different piece of code, piece of procedure to make your system already compliant to what the blueprint has stated.
Yes, and do Kubernetes and Docker do the same to containers like hypervisor do for VMs?
No, this is completely different. The hypervisor will give the abstraction layer for the virtual machine to run as if they are in the proper environment. This is what the hypervisor will provide to the virtual machine. But now Kubernetes will be only a controller that will be a controller that will give the different ability for a container to run here or there, or have a state of running in on the search in this node, or if there's a high availability requirement, to make sure that no matter what happened, the system will make sure that this container can be spawned in different environment to make sure that it's high available. So this is what Kubernetes is doing for the containers. So it is different. It's completely different. It's completely different approach. So to run a container, you need to have at least a kernel that provide the container capabilities, or you need to have a Docker engine that will help you to run your container on your virtual machine or on your bare metal, if the bare metals are your server that you are using.
Yes, and here we have like when it is considered as overdoing for the microservices. When is it considered overdoing, and does this have any effect on the infrastructure?
No, I do not understand.
Have you mentioned something about overdoing? When is it considered overdoing? Like when we overdo the infrastructure?
No.
For microservices, when is it considered overdoing for microservices?
Okay. No, microservices is not overdoing it. If most your system is break into small pieces, more it is good. You can manage it better. And that's why you need tools like Kubernetes, all those tools that will help you to manage all those small microservices across your different environment. You can do it by hand again if you don't have a lot of infrastructure to manage, or if you don't have 1,000 of containers to run. But if you are going to at certain level of containers to manage, it's important to have toolings like Kubernetes that will help you to manage and make sure that, okay, your containers, the way you have defined it, are working, and all the microservices that you have defined are available. And if, for instance, it's not available or it's not working somewhere, it can be shipped and respawned somewhere else to make it available. And yeah, so this is the stuff you need to take into account when it comes to microservices.
Yes, and then we have a thank you here for the presentation, and I would like to know what is the difference between WSL, like Windows System for Linux, instead of a tool like Docker.
Yeah, they do the version the Windows to run Linux code change a bit. I have created a change in his kernel of operating system, a library that will give all the abstraction layer for you to run your code inside a kind of a jail environment where you can run your code, your Linux code inside the Windows machine. So this is not the same approach. But again, this ability leads to what we can have if you want to run your container, your container in Windows. You can also have your Docker for Windows or your container environment for Windows. So it is the same philosophy, but it is two different technologies. Yeah.
Yes, and then we have a comment from Bozer here that we can use Podman instead of Docker. Thanks, Bozer, for the comment. And we have a final question here, like, where does Jenkins fit in the CI/CD pipeline?
Yeah. Yeah. That's a good question. Jenkins in the we used GitLab for the CI/CD, but because GitLab has the Git version, the Git part, and then has what we call a runner. So the runner in the GitLab will be the one doing all the pipeline processes. So instead of using GitLab runner, some people will use Jenkins. And then this is where Jenkins also fits in. So, but you still have your control, your source control version, and can be in Jira or can be Circle CI, can be Bamboo. There are a lot of Tecton. There are a lot of CI/CD engine to run the pipelines. And then me, I'm using GitLab Runner to 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 do my pipeline. People can use Jenkins. People can use also Tecton or Bamboo or Sequoia. Yeah.
Yeah, yes. Now I think we have answered all the questions there in the chat. If we can go through the practical part of this workshop, yes.
Yeah.
Yeah,
Yeah.
I think we're already behind time. So sorry guys for just taking extra time from this, because I know
No.
it has been difficult just to shrink an 8 hours workshop in just 2 hours. So yeah, we'll do the practical part. So yes, Danny.
Yeah. I don't know if you are able to connect to the platform. If you are connected, you will see. I have a tutorial Day-1 building a cloud infrastructure where we are going to look at we are going to do all the process of using the git command first, and then we can go to some item to show you how is it really about, and we will have I shared? Okay, I think my screen is shared, right? Can you see my screen? Mohammed, is it?
Yes, we can see your screen, Danny. Yes.
Okay. See if. Sorry for that. Okay. Sorry. So we are going to for if you the idea is to go to this tool to web page where I've created for you to be able to follow what I've started as well. And then the Git is one of the tool that we are going to use to control the version of the code that we are reading. And to install Git, you have to, there's a website you can use, or you can go on the GitHub to have the Git desktop, or you can go on Mac if you want to have the Mac version as well. It is if you have it, if you are on Linux, you can go on git.scm.com to have your Git available. You can install it through a normal command in the different platform CentOS by doing DNF install Git, or yum install Git if it is on Ubuntu, apt install Git, and all those. Me, I have it uh, is it pause? Can you
No, I think you're live. Yeah, it is.
can you see my shell? My shell is available or not?
No, only the web page.
Okay, the web page. Okay, yeah, I think is. Let me reshare it because I think the way I've shared it is not. Let me share. This- Now, can you see my shell or not?
Yes, now is the shell.
Is it well displayed, or is it
Yeah,
okay?
yes, I think the font size is okay.
The font size is okay. Perfect. Okay. Then to configure the Git, you have to, there's a command. I will not go through all the command. You can go and do it on yourself on your side. But first, it's important when you are using Git to identify yourself. Why is it important to identify yourself? It will be the key item for you to tell exactly who is doing the changes and who you are. And then once the code is committed and is validated, it will give the opportunity to see who is doing these changes. And if there's a comment, you will also receive a notification saying that, okay, what you have done is not has an issue or is not okay. And then if there's a review, we can address again this review through the email. So when you are installing a Git, you need to configure first your name, and then set your email address, and then you can also, if you want to have the color as well, you can also set the color as well if you want to. So to configure your Git, you need to do what is basic. You will say git config global here like this, and then you set your name, then global user.name, and then you set your name first. Um, and then once you have that, I can say, yeah, if I want to. Okay. Hold on. You can say if my name is Daniel, I will say git username Daniel, Afanko Daniel. Yeah, that's it. So let me create a directory in the /tmp sample cd. To initiate a Git repository, you need to do git init to initiate a Git repository, and then you have your repository sets over there, and then you can let's go to yeah, you can do the git status to see if you want to. Let's go to touch some. Then if I do git status, I can see that, okay, I have the branch, I'm on the branch master commit, no commit yet. And then I have an on-track file. The on-track file, that means that I have a file is not under the Git control. And if I want to add this file to the Git control, I need to use what I have below. You say I have to use git add to start tracking this file. So I can say git add SdNOG, and then my file, sorry, and then my file is track, is on that track. So I have now my branch say that I'm still on the master branch, and have here and no yet committed, and I have on the staging environment. So it is important when you are using Git to be aware of the staging environment and then your committed environment. The staging environment is where all your changes is happening. And when you are doing the commits, then you validate your configuration or your changes. It will go to the commit version where it's like you validate your changes. And you can roll back and do whatever need to be done if there's a mistake or if there's something wrong with what you have. Then if, for instance, I use, let's use all those git diff, git add you have, and then if I do git diff, because there's a file added and there's no updated, so there is no committed version, so my git diff will give me nothing. But if for instance I have my file on that track, I say, okay, git commit 1am for all and m for to add a comment, text file, a new text file added. And then now my changes is committed. So I'm not in the staging mode anymore, but I'm in the committed version. And then if I do git status, you will see that seems like there's nothing to commit. My work environment, my working tree is clean. But if, for instance, I do a change into the SdNOG and I say, okay, hello world. Now, if I make a changes, you see that now I have like a changes in my file, and the status is modified. If I want to see all the changes that I have in this file, I can use git diff and set the name of the file, or just SdNOG text to see the changes that I've set on this file. So if you see the same file has nothing before, and then I have hello world added. Again, here, if you have question, do not hesitate to interact me immediately, because it is also important to have all those questions immediately. Mohammed, if there's a question, do not hesitate to jump in and ask me to do so, to avoid going to the end and then have to come back again to what we have already done and completed. So here
Yes, sure.
it will be quite interactive. If there's a question, do not hesitate to pin me. And then if, for instance, I made a change to my file and I want to discard this change, I will use a git checkout dash dash, and then I will say SdNOG. And then if I discard these changes, if I say git status, so my environment is clean again. And then if I do cat SdNOG, it's still empty, because I've discarded all the changes that I made on my file to make it reflected the previous state of the code before the changes. Okay, let's open again. Let's do echo hello world, and then SdNOG. And then so I have my file updated, and then if I do git diff again, I have this version. So if I want to show the difference between the staging and the last version of the file, for instance, let's do it this way then. So let me do git commit. So I have updated my file, and then if I do git status again, it is clean environment. But now if I do git diff, I have nothing, because I already validated my configuration, and it's still a clean environment. But now if I would like to see the snapshot of what I have before, I can say git diff stage to see the stage version. But here again, there's nothing. But if, for instance, I've added echo hello if I'm doing this and I do this, I can see the changes that I've created. Then those are but you can go on the website of Git to see all the action you can do to see all the changes, how to see the diff and all those on the Git. If you want to start using the branch, we can use git branch to see the different branch that we have. And if I want to create a new branch, we are going to use the git checkout, the branch. Why is it important to create a branch? A new branch is to create a different environment where you have here, check out my B. Yeah. So what I've done is here is to I've created a new branch hotfix, and I put the changes that I've done on this branch. So if I do git status, now my branch is now on hotfix. And hold on. Now, if you can see, I have two branches, and one, the active one where I'm located, is the hotfix. And what I have on hotfix is the changes of what I've done on the file itself. It's status. So the changes that I've done here is on the branch hotfix. So if I, for instance, I switch to the master branch, my file will still unchanged. So if you see here, here I have hello world and then SdNOG. But if I do git checkout master, now I switch to master. Then if I do git, yeah, because it's still in staging, it's still in staging mode. And then to I can change if, for instance, I am going to, hold on, let me go to hotfix, and I do git commit update in hotfix. Now I've done the git status. Now there's on the hotfix, and my SdNOG had those two rows. But if, for instance, I do the checkout master, now I switch to master branch. So my file has kept only the change that I have on the master. And it's not, the changes that I've set in hotfix is not available in the master branch. This is a way of doing the versioning. So if I'm going back to hotfix again, and if I do git to see if to see all the changes that I've done, I have to do the git log, and then the git log will give me all the changes, all the item I've submitted, and then where, and if, as you can see, he's telling me the author. So this is why it's important to have the author well stated, because the author will be the one that will give you an idea of who is doing what and who has submitted what. And then if you want to relocate or remove a version file, you have to use git remove the file. And then if you want to delete it from the cache environment, you have to do the git remove cached file. Those are the action that you need to know when you are doing the versioning. And then so we are not going to spend too much time on those items. Again, the comment on the git is so huge and is so big. You have to go on to different details and practice, and you can use this small memo that I have here that will give you all the different action items that you have to use to do certain things. we are not going to spend too much time on different tools, because there are a lot of tools that we need to see. And then if you are spending too much time on every tools, of course we could not complete the entire agenda. And one thing you need to know on the Git is you can have a centralized version of the code located somewhere where you can push your code in there, and you can even retrieve it from this location if you want to. And then once it's done, you can push back your code over there. Let's, for instance, look at what I have I've created here. I have a repo on my GitHub personal account, but you can create your own code on your own account as well on GitHub. I invite everyone to create his account on GitHub or even on GitHub to start a community, because it's important to share your code and make your code available for not all of code, but yeah, most of the code that you want to share with people. Yeah, because it is a open source and community project. Yeah, now to clone a repository, why is the clone is what is like I have a central repository somewhere, and I want to make this a copy of this file of this repository on my local environment. This is what we are going to use git clone, and then you specify the path. The path will give you, can be HTTP, can be HTTPS plus SSH, or can be only a file located on your machine or on a destination. And then once I will clone the repository, this one is cloning into demo, and then the demo is empty. Then I can go to the demo and then do. There's nothing on this demo, so let's do again the touch sample.txt git status, and then I have an empty file here. So if I want to push my changes to my repository, I would like to first to add this file. Git add the file. The dot is representing everything on your path or current path, and then you have to do git status to see if you want to commit git commit. File. Now, if I'm trying to do the git push, it will complain. It will ask me for my credential. Either I specify my credential in the configuration and I can do it immediately right away. Either I specify also my keys, SSH keys for the repository to be able to to push automatically my configuration to the central repository. If I don't have all those two mechanisms enabled by default, it will ask me to set my credential and my password. So yeah, I'm still remember my fail. If I do not remember, it will be okay. No, it's I don't remember my credential. That is weird. But again, it's okay. It's not working, but it doesn't really matter. It's okay. Again, you can go onto the Git repository to change to see how the Git works like. And then comes into a place where we are going to use one of the important tool that we describe the configuration file, what I used to call infrastructure as code. So when you're talking about infrastructure as code, is a two piece of item that you need to take into account. The representation can be a file. This file can be a documented file, can be something written in XML, in the configuration, but something where people can read. XML is not a sweet example because XML is too hard to to read. If you if you see how XML looks like, I'm not sure you will be happy editing this code. But we need to come up with something easy to read, easy to understand, and that will make a consensus when it's about doing all the changes. So that's why the YAML is one of the syntax that is used heavily, actively in this way of documentation. And then the YAML is a simple basic way of documenting file. And then you have the three dash that describe the file, and then items are listed this way. So if I want to, so you can have also some editors that will that can help you to edit your YAML file. So I can say fruit. So yeah, this is how a YAML file can look like, but not only. This one is a set of array, if I would like to say it this way. To have a kind of a record for a name, we are going to use something like the indentation is important. So we have a key for a dictionary for, let's say, if I want to describe a server, I can say I would like to, let's say, let's group the server located in data centers. So I can say I would like to have, let's say, server 1, and then server this in this server I would like to have, now I use the 2 annotation. I can say the name, and the name is everyone, and then the IP address can be 0. I can say prefix 24, and then I want to say gateway. Yeah, this can be my IP address. Can be set something like that. Yeah, it can be if I want to add something, I can add suffix, and then I will have yeah. Yeah, it can be something I can describe this way. So this is my git diff first. Oh, yeah, because I didn't commit it, so it's okay. Yeah, this is my configuration file describing my file again. But now, if I would like to have a different array of item, I would like to have server 1, server 2, server 3, and server 4. How should I do this? Let me say this one. So the people will say the best way of doing certain things will be to have something like this, where I have now server 2, and then I put 2 here, and I put, let's say, yeah. So this is server 1, server 2, and server 4, and so on and so forth. But that means that if that's the case, if I have this such design in the naming, that means that to access the server name here, I need to know that the server is named server 1, the server 1 is named server 2, and so on and so forth. So what it does can drive in, it can drive to a confusion if, for instance, here, instead of naming this one like this, and I name it like this, I name it server, let's say 2E, and that's it. So if that's the case, there's no way for you as a developer to know that, okay, now it's not server 1, server 2, but there's server 1E. And it can lead to this one will be unavailable because you don't have idea of this small e, small I. I mean added to to this naming convention. So to avoid such a mistake, what will happen is, instead of having this naming convention, let's have something different, where I will have now servers here, and instead of having this naming convention, I will add something like this. I will have something like this, where instead of having to remember that I have server 1 and server 2 and server 2E and so on and so forth, I will only need to have, like in my nomenclature, in my naming convention, only servers. And then in servers, I just need to say no matter what you have inside servers, just loop inside all those items. So here, sorry, I've stated the same stuff here. Yeah, now I think it is much better. Yeah, now I would just need to loop inside all those two items, and then I will have a looping, and then I just need to remember the servers, and that's it.
Hi, Danny. Sorry
Yeah.
for stepping in.
Yeah.
I just wanted to mention that for SdNOG, we have a line course about Ansible. So it will teach them all these details. Yeah, it's online. Every participant will have machine, and they will show them how to deal with the YAML file.
Okay.
The best practice is to write your YAML when you want to call, or when you want to have a function, for example, to call all these variables. So
Okay.
everyone interested to know more details about Ansible, because it's also a very long thing or very big things to know. They can subscribe for that course to know all the details.
Yeah. So we switch to Ansible, or we can go but more faster. What you suggest?
I think, yes, we can just go more faster because we have only 15 minutes left. So if we can have just a quick look for how to use Dockers, how to tie all these tools together, and wrap up for 15 minutes, that would be great.
Yes. Yeah. This is what I have But again, you have all those items here in the basic to see how those things works. And then again, as Sarah said, we are not going to go to all those details. And then the variables again are mentioned this way, and then you can with the two code, and then you can access the variable automatically. And then yeah, so the yeah, I think it is in YAML you will have to deal with a different let's say cast of a variable. If for instance I say let's say if I say for instance a prefix, let's go for a prefix. If I say prefix 24, it will convert it automatically to integer. But if I write it here like this, it will be considered like a string. The string are the character. If quote or double quote are the same, but it depends on what you have to, what you are trying to set in the code. You need to make sure that there's if you have inside your code another item with another code, you need to escape your code that you don't want to be taken into account. And then yeah, those are the most important item. But again, a YAML is quite interesting to know, because all the action that we are going to do afterward will be solely based on this Ansible, on this YAML structure. And then we are going to use a Docker. Docker is a it will be our container environment where you have your Docker. You can see here, you can see Docker. Oh, go ahead, sorry. And then you can have, yeah, so this is the version of container that I have here. And to see the Docker also will use what we are going to call registries to pull your images from a location from that registry to your local registry. What you are going to use is to see what you have in your local registry. You have to do Docker images. And then when you do local images, you will see what are the registries that you have here. But I have a lot. I have a lot. And then because it is combined with also Kubernetes registry as well, that's why this is so big. And if you want to let's try to follow to see all the running containers you have here. You can just say the PS to see only the running containers. But if you want to see all even the stop containers, you have to add the -A to mention the all. When you run a container, you need to first to pull an image. But if you say, I want to run a container and a container is based on the image and the image is not available on your machine, the first action will be to retrieve this information from this image from the repository where you have access to pull this information, and then it will put it into your local registry, and then from your local registry it will be spawned like a service for you to start running your application. So either you do only first a pull. Let's say if I want to pull my CentOS machine, I will use CentOS. I can specify the version of the container if I want to, but if not, I can just say CentOS here. It will pull the latest version of the container automatically for me. So let's say that's just one. It will use the latest version, and it will pull it automatically. Once it's done, you say yeah, it is okay. And yeah, okay. Now, if I want to run this container, I will just do the car run minus IT. IT is interactive. The T is for the terminal, and I would like say dash remove, just to remove the container once I'm exiting. If I exit the terminal, just remove the container itself. And then I say a name to name it SdNOG. CentOS. And then I need to add what we call a bash. The bash is important to, a shell is important because when you are running a container, what will maintain the container alive is a process. And if there's no default process, the container will exit and die. To make a container alive is you need to have the process 0 of your machine, of your container, to be enabled, and it should run a process, and can be anything, but this process need to be kept alive. If it's not for reason this process is stopped, your container will also die. Because the idea, this is the how the container are built. The container are built based on the process. So you virtualize an application, and this application need to have an active process. And once your process is still up and running, your container is running. But if, for instance, your application is not running, there's no reason to keep this container running. This is by design. So to run our CentOS machine, oh, hold on, I've made a mistake here. So I need to specify my image. So I'll specify I want to run Docker run manage IT interactive terminal, remove the container if I'm exiting the terminal. I set a name of this container, and then I need to specify what is the image that I want to use to run such application. And then I use CentOS, and then yeah. So this time we use the CentOS, and I have my system now available. Yeah. Now as you can see, I'm in my container. If I see now cat. It is I'm a CentOS release 8.2. If, for instance, I'm exiting and I want to run the same container, but here I want to use an Ubuntu. So I don't have Ubuntu locally. It will pull Ubuntu for me. And then I have the latest version of the Ubuntu available. And then here, if I do the release, I'm the Ubuntu distribution 25. And then what is also, why is it important to have such things is like here, if for instance, I want to test my code of deployment, I can spawn a container and start doing my, doing all my action like a terminal, my Windows, my Ubuntu, my Linux machine, and do all my deployment process as normal, like a basic, and do whatever need to be done. And yes, because before I didn't have a VM, but now I have the VM, I can do whatever need to be done. And yeah, so this is a way of doing it. So once I'm exiting, the container will be removed automatically. And then by doing that, again, I'm doing something manual, but that's not the case. What hold on, okay. What will come into place is in this way of running an image, a Docker file. So let's say if I want to create a Docker file, I would like to say only by default, the system will look for something called Docker file this way. And then this is where I need to tell what will be the image of what I want to run. And I will say the image, I can say CentOS. And then I can say run. Because it's CentOS. Let me pull a CentOS 7 and then update. If I want to, I can use also DNF update. It depends. Then I'm just going to use. Then to build it, I will use docker build minus t. I would like I can build minus t. I would like to call it SdNOG. Build, and then we have to say here, just build it here. Oh, what have I heard? Maybe it seems like I've done something bad here. Sorry. Oh yes. Oh. Oh, sorry. Yeah, it's like if I want to build, it's like here from and then run. Yeah. So yeah, because I can. It seems like I'm too tired today. Why so? Yeah. Okay. So the idea is to run your code like this, and then what is doing is instead of creating the image and doing all the code, I created a Docker file that will trigger all the action that I've set in my configuration, and we do exactly the same thing. So I can replicate this environment. So now I have my image tag for SdNOG build, like a latest version. And now if I want to run this image, I just need to do docker run minus it again, SD. Okay, now I'm still in my CentOS machine, but I have already done the update, because now I don't need, there's no update to do, because I'm having this image, this new image that has already the update that I've done, and it's available. One thing's also important when you are using Docker is you can expose some port as well. When exposing the port is, I would like to say I have a service that I want to run, but I want to make it available on a particular port. And then you have to do, to expose a container using the port, you have to use, let's say, Docker run one. Okay, I can still do that. Yeah, if I want to. Let's say Nginx, and then Nginx is a web server. And then if I want to expose a port, I want to say, here I would like to expose the port on the, let's say, yeah, I want to expose this port, and I say, okay. Okay, so there's no Nginx image available on the machine. The system will go and fetch for Nginx machine. That will automatically spoon and make it available. So yeah, because there's no, it cannot run. There's no entry point. Oh yeah, it is the way I've yeah, this is yeah, now it should look much better. So there was a typo in my code, the way I've tapping. I mean, it's like I've say run the Nginx and in the Nginx, and that's it. So it's not the right way of doing. Yeah. So this is how now I can now make the container available on this port. So if I do Docker, of course I'm already in the container, and if I want to see, I can go to that port and see if my system is available. Maybe because I'm on the VPN. Also, another way of doing it is to make the system run in the background, and then you need to add -d to make it run in the background. So once the system is running in the background, I can look for, yeah, it is here. It's available at this on this port, as you can see. But I think I've done, yeah, this is Yeah, this is the page. Because I was on the. Can you see my screen or not? Mohammed, are you see?
Yes, yes, you can see your screen. Yes.
Okay, yeah, this is the Nginx stuff. Because before it was not working because I was on the VPN and my VPN was redirecting all my traffic and
Okay, okay. Very good. I can see people are leaving here, Danny, already, I think, because we are behind time. Maybe if you can wrap it up and then maybe if you can tell us about like the resources that we can use to find
yeah,
all these commands and then because people will be practicing all these commands
yeah.
after
This is
the workshop.
exactly.
Yes.
Yeah. So if you can see, you can practice and you use. It's like you can go to this web page where you have. You can link it to the repository to the documentation as well, where you have all the it's quite a straightforward action. And then here you can have let's say let's go. I don't know if you can go for the Docker compose as well, but if not, I can. It's still okay. We can but you can go to and see how it is quite a straightforward process. Uh, let's say what will be the Ansible for beginners. Ansible for beginners. Yeah. Here as well is here's where you have your Ansible for for beginners, where you can now start see how to use Ansible, and then Ansible will be one of the tools that we'll use mostly to automate your process. Again, it will use the YAML, as Sarah said. There's also a tutorial that will help you to do so. Uh, in my hold on, created I've exited by mistake my container. I don't know if you are also familiar with Python virtual environment. It can also something you can also. It's important if you want to have different version of Python running your code and have different environment that runs in parallel is also important. Here I have a version 2.9 of Ansible, and Ansible has a kind of configuration file. Here it is Ansible. It is written here. I'm using. There's no configuration file, of course, because I'm using a Mac, and then there's a configuration file found if you have, let's say, if I use like Docker. Um, OS. This is why it is important to if you want to have uh, CentOS. Okay, here I can say I can do your install. Okay. Now, if you now you have now your file in Ansible, uh, what have you? As you can see, I'm on Mac, but I'm using Ansible I'm using Docker to so this is the Ansible default configuration file on CentOS, and most of the Linux RPM-based configuration, where you have other configuration that will help you to do a global configuration. If the file is not available at globally, first at locally, it will fetch it globally, and if it's not, it will use the default values. So here we can use Ansible minus m being uh, uh, because if I want to do the ping version, it's like here I would like to, yeah, because I don't have a configuration file set by default. Uh,
Are these commands all available on the web
the web,
page?
yeah, this is where all comments
Okay.
are available on the web page. This is
Okay, that is
what I
very.
will,
If you can just, yeah, maybe we can just share the links with all the
yeah,
participants, and then they can go through all the commands,
yeah.
try
So
them
yeah, this is
by themselves, and if someone faces any problem, then
yeah.
they can get back to us through the mailing list or maybe the comment section on YouTube. So I think, yeah, by this we can
Yeah,
maybe.
so sorry to not be able to go through all those.
Yes, yes, actually, because we don't expect it because we used to have these workshops we used to do them in 8 hours. Do you remember,
Okay.
Danny? 8 hours for 3 days. So I understand, yeah, it's very difficult to have an 8 hour workshops in just 2 or 3 hours. Yeah, it will be very difficult. And that is why we will always respond to all emails, questions that are coming
Yeah,
to the mailing list, or the questions related to Ansibles or Docker or GitHub for that instance. So yes, uh, we will send all the links to
yeah,
the participants here, and then we will just go through the websites. And if you have any questions, please do send them to us in the mailing list or in the comment section on YouTube or on our Facebook page. We are active in all the social media
yeah,
sites, so you can just connect to us. If you want to contact Danny, then his email is there on the slides. And yes, I if you have a final word of thanks, Danny.
yeah. I would like to thank you. Was quite short this presentation, but I would like to thank you for attending. And again, it is quite a huge topic, and it will be fine to have you uh, connected to the project, or even to hear if you want, if you want to know more about what I'm doing or what we are doing. It can also be interesting about doing the cloud computing. And again, the idea is to have a cloud infrastructure different from what Amazon and Google and Azure are doing, but closer to that vision, but something distributed across Africa region. where we can have our own infrastructure hosted in Africa region, where we can host a virtual machine for doing such a labs. You can also contribute by by your skills, by your time, providing content, providing uh, skills at any level, because the idea is to create a boundary in between our community, no matter where they are located. And yeah, feel free to join us. And it is also a pleasure to have you. Unfortunately, we didn't have chance to complete all this process and see how tools are working together. It's quite a long topic, but in 1 hour and a half, it's quite short. But we will have time to go through all those details. But again, once you have all the idea of building the, the cloud, I think it's the more important steps to be able to build your own cloud infrastructure, because it's only about the principle, and the other is only the implementation details. And the information details, there are a lot of documentation available, and if you know exactly where you are going, the documentation will only help you to achieve it and go faster. Yeah.
Yes, very good. Thank you very much, Danny. Actually, you have never hesitated to help the African communities, and inshallah, next year we'll have SdNOG in Sudan, and we will definitely invite you to deliver like 3 days or maybe many days workshop there. Yeah, because yeah, I know that everyone here is eager to know more about the cloud infrastructure and how to build their own cloud infrastructure. So again, we would like to thank you very much for this. It has really, it's very much appreciated, and yeah, just keep it up. And thanks everyone for watching. And but meanwhile, if you want to ask any questions, just please do not hesitate to share your questions on the mailing list. And please do not forget to take pictures and then post them online under the hashtag SdNOG, the hashtag SdNOG-7. So yes, thanks everyone, and have a great rest of this day. Thank you all.
Thank you.
Thank you, Danny. Hope to see you next year in Sudan, face to face.
Yes.
And we will have a complete workshop next time.
Yeah, definitely. Yeah, this one was quite tough, and yes.
Yeah, sorry for that, but it's also we have few minutes, limited time, few hours for everyone to join.
Yeah.
And it's almost end of the day here for all the workers or all the people who are working. So yeah, we could not continue more. But definitely, if we got any questions, we will forward them to you. And yeah, let's see. Thank you for your time, and thank you for your continuous support for Africa and for SdNOG.
It's a pleasure. Thank you too.
Okay.
Thank you. Bye.
Okay. Bye bye, Danny.
Bye.